Hello and welcome to another video. In this video we're going to be working on minimum time difference. And in this one you're given a 24-hour clock in our minute format and return the minimum minutes between any 2 points. So here there's 1 minute, and then here there's 0 minutes because these are the same. So the first thing we can recognize is if we have 2 times that are the same, we can just return 0, right? Because there's 2 times, there's no minute difference. Second thing is when we compare these times, we also have to compare going around. And what I mean by that is, like, let's just say our times are in minutes here. And so, let's see. So the maximum time is 23:59. Or I guess let's write it out first. Let's say our times that we have are like 1 hour, 3 hours, and then 23 hours, something like this. So here, actually, imagine if this was an array. Like normally, when you compare to find the closest elements next to each other, you can just compare 2 elements that are right next to each other, and then it's guaranteed that the smallest difference is going to be between those. But actually, here we also have to wrap around. So actually, here the smallest difference is 23. Well, I guess here it's the same, but let's say this was 0. Then this would be 3 hours, this would be 20 hours, and this would be 1 hour. So not only do we have to compare elements that are next to each other, and if we had these times sorted, we also have to compare the last to the first, because wrapping around might be the best. Okay, and now there's 2 main ways to do this comparison, and one way is, and they both involve, so I guess we can write that as step 3. Take the times as a string and convert to something we can compare, right? And because we're asked to get the minute difference, we can just convert time to minutes, right? So we can just say, let's take the hours. What's the conversion of this time? It's just hours. For every hour there's 60 minutes plus the minutes, right? So for example, 23:59 would be 23 times 60 plus 60. And then when we get all of these in minutes, there's 2 ways of doing this. One is to sort, right? If you have a sorted array, and you're asked to find what are the elements that are closest to each other, well, you can just compare every 2 elements that are adjacent, and the answer is going to be there. Or, like I said, this wraparound thing where the last and the first. And so that would be n log n. The other way we could do it is we can still convert all these, but then we can just store these times in a hash map or an array or something, and then instead of sorting them, we can just do a counting sort. And basically what a counting sort is you have numbers in a dictionary or array or something, and you can figure out where the start and end point is. So you could say okay, my smallest time is something, my biggest time is something, and I can just manually check, do all these things exist? So the basic idea is I can have an array of all available times possible, right? So I'm going to have an array from 0 to 23:59 in minutes, and then I'll just say okay, I'm starting at some time which I can find by getting these times. So let's say I'm starting here, and then I'm ending at some time which I can find also because I can just get these 2 things as I'm getting the times, right? You can just record these 2 values. Or even without this, I can just say let me just start at time 0 and go all the way up until this. And the basic idea is in some of these slots there will be times, in some of these slots there won't be times. So maybe this thing exists, maybe this thing exists, maybe this thing exists, and so on, but some of these won't exist. So you're just gonna have this huge array of all possible times, or dictionary, same thing. And then you can basically say okay, let me just start at some time, and then anytime I find the next time, so I'm just going to keep looping forward. Anytime I find the next time, I'll just compare it to the previous time I had. And then same kind of idea, your answer is always going to be times that are next to each other in a sorted array, but you don't need to sort it because you can just manually look and check if the elements are actually there. So basically what would happen here is let's say our times in this situation, let's say we don't have these hours at all. We just have numbers, our possible range we can have is numbers 0 to 9. And the numbers we happen to have are 0, 2, 5, 8. And they're not sorted, right? So they can be 8, 5, 0, 2 or whatever. So the first thing is we're going to make an array of all possible numbers we can have. Then as we go through all these, we will mark off the ones we have, and then we'll just say like, okay, let's just start at like the first number we have, which is 0. And then let's just keep manually going through this array to see if we can get to the next one. So like 0 exists, 1 does not, so we keep going. Then we get to 2. And we'll say, okay, we have 2. So let's compare 2 to 0. That difference is 2. And now we don't need the 0 because we're only going to compare numbers next to each other. So now from 2, we just keep going and checking for the next number. Nothing, nothing, another 1. And we compare these two, difference is 3. So now we don't need this, and we keep going. 1, 2, 3 again. And then we just go out of bounds, so we're done. So our best, not including the circular loop, obviously, is 2. And then you do also have to check the circular loop. And like I said, to do that, you can just record the smallest and biggest number. So in this case, the circular loop would be 2. It would be 1, 2. And this is the same exact thing with minutes. We're just going to have a bigger array. Instead of 0 to 9, we'll have like 0 to 24 times 60. Same kind of thing. So basically, the idea of a counting sort is you don't sort your numbers, and you're just kind of like manually checking. And that works pretty well, assuming your range of total numbers is smaller or kind of equal to the range of the size of the array. So like in this case, this array is 10 to the 4th roughly. Sorry, 10 to the 4th, which is 10,000. And the all possible numbers is only 24 times 60, which is like 1,500 or something, right? So they're about the same, like in terms of big O, but by using a counting sort, this is basically linear and we don't have to sort the array. So that's kind of the idea. Now, you know, if this was 10 to the 4th, but the numbers could be like from 0 to 10 to the 9th, then you wouldn't want to do a counting sort because you'd actually have to loop from 0 to 10 to the 9th. So taking this and doing a sort is better. So it basically just depends on like what's the range of my possible inputs and what's the size of the array. And yeah, so let's take a look at that. So essentially we get all of our times that are possible. And I just made it Boolean because, like I said, if we ever get 2 times in the same time, like if we, like once we're converting this to time, if we ever get the same time twice, we're done. Because if we have 2 at the same time, then the minimum difference is 0. Then we get our starting number and our ending number. These aren't really needed, but it's fine to have them. It just makes things easier. So basically start would be like the starting number we're starting to loop on, and end is the ending number. And then we go through all of our times. We just convert it to hours and minutes and a total minutes. And then if we say, if we already have this in here, then we're done. If not, we'll turn it on, and then we will update our start and end. So start needs to be the smallest number we've seen so far, end is the biggest number we've seen so far. And then basically this min difference is what we're returning. So I initialized it to this loop, right? So like if let's say your start and end is here, or let's say your start and end is like 6 hours, and then you have a bunch of numbers in between those, and then your end is like 18 hours. So I basically said, let's just initialize our output to be, because you always have 2 numbers, let's just initialize our output to be the circular loop. So in this case, it would be 18 to 24 plus 6. So it would be 12. I guess to make it clear, let's make this number 20. So if this number is 20, basically the circular loop is we'd have to go from here to 24, which takes 4 hours, and then from here to 6, which takes 6 hours. So this would be 10. So that's what I initialized our result to, the circular nature of the clock. And this is what I said, like usually I just make a solution and then you can just put it into GPT and just say like clean it up and write comments and stuff. So it's pretty convenient. It'll basically like, it's really good at taking something that's already done and making it cleaner, not the best at like actually coming up with it. So anyway, so then the previous time is where we start. And then the basic idea is just like we go through from our start to our end. And anytime we find a new time, we're going to calculate the difference between our current time and our previous time that we have stored. So kind of like I showed you here, right? Like basically previous starts here, and then we look for a new time, and whenever we find a new time, we compare it to this previous time. Because it's still the same idea. In a sorted array, the min difference is going to be between elements that are next to each other. So like once I pass this number, I no longer need this number because these bigger numbers are not going to be closer to this number than they were to this. Yeah, and then you just basically just loop through the array, so it's a linear time loop, and then you just return your answer. Yeah, so there's not too much here, honestly, just like convert time to minutes, and then the sort solution should be like super straightforward to figure out, like basically in a sorted array, and the shortest distance between two things has to be between elements that are next to each other. And you can prove that pretty easily, right? Like if I'm comparing 4 to numbers before 4, the closest one is going to be the one right next to it, because anything past that will be farther. Same thing here. The closest is going to be the next thing right next to it, because everything else will be farther. Yeah, and the circular one. So pretty much it there. Yeah. Okay. And yeah, so hopefully it makes sense when you would want to pick like the counting sort, when you'd want to pick a normal sort. Counting is linear, normal is n log n. Basically, it just depends on this array length and the total number of inputs you can have in here, which in this case, they're roughly the same. So then I would just take the linear counting sort. Okay, so here. So we basically have to make an array of times, which is 24 times 60, which we can call it constant, I guess, because it never gets bigger. We have the start and end. We have to loop through all of our time points, which is, let's call that n. Convert them all, put them into the array. And then we have to loop through this thing again. So let's just call that constant time, because these never change. You can make them smaller if you want. You can make some optimizations like, well, no, I don't think it would even optimize. I mean, you can make this array smaller if you record the start and the biggest and the smallest element in a loop first, and then make this array. Then you can make this array smaller, but it doesn't really matter. And in Java, it's more efficient to use arrays and dictionaries, so you could totally use a dictionary. I think in Python, when I did this, I did use a dictionary, same kind of thing. You just use a dictionary instead of an array. Yeah. And then space. Let's see. So like I said, I'm going to say this is constant, or you could say it's like 24 by 60 or whatever, however I'm in it. And then this is all constant. Yeah, so I'll just say it's constant, or like I said, you could say, if you want to say it's not constant, you can say like, I guess in my thing, I always made it like this, but you can also make it like the min value in here to the max value in here, or something like that. If you use like a hash map, I guess that would be that, but whatever. As long as you kind of like know how to derive this, I don't think it matters too much. I'm curious also what this will say. Let's find out. Okay, interesting. Okay, but yeah, it's gonna be all for this one. Hopefully it's helpful. Not too much of a hard one. And if it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.